This is a video on solving systems of equations using the substitution method. And I think the easiest way to see this is an example. The thing to remember though is when you solve a system of equations, what you're really trying to do is find the ordered pair of the coordinates where the graphs of the equations would intersect. So we'll do this through an example, and I'll write steps along the way on the first example. So if I said to solve by substitution. Now it might say solve algebraically. And if it does, there's another method we're going to learn later that will explain how to solve a different way algebraically. But this is how you do it using substitution. So if I said negative 2x plus y equals 10, I'll label this equation 1. And 3x plus y equals 5, which I'll label equation 2. And I'll write the steps along as I go. So the first thing you want to do when you're solving by substitution is you want to pick one of the equations. All right, so pick an equation and isolate one of the variables. So for the purposes of this example, I'm going to pick equation 1. All right, so I'll put this in little quotes here just so you know what I did. So I'm going to pick equation 1, and I'll choose to isolate y. So you could have picked equation 2. It doesn't matter which equation you pick. You could also pick to isolate either variable. The reason I'm picking to isolate y is because I notice the coefficient's already 1. So it's easier to isolate that than it is to isolate something that doesn't have a coefficient of 1. And you'll see that through some other examples as well. So I'm going to pick equation 1 and I'm going to isolate y. So equation 1 was negative 2x plus y equals 10. In order to isolate y, get y alone on one side, I'm going to add 2x to each side. So I end up with y equals 2x plus 10. Remember, the sign of the 10 is positive because 10 was positive, so it's a plus 10. Positive 2x makes that plus a positive 2x there. Once we've done that, we're going to substitute what I have for y into the other equation, right? So I'm going to substitute, just keeping this general, substitute the result from step 1 in for that variable in the other, and this is important, right? In the other equation. So if I started with equation 1, I have to substitute what I had into equation 2. So in our case, we're going to sub, just so you see it in words, right, we're going to sub y equals 2x plus 10, which I just found a second ago, into equation 2 for y. So equation 2, going back up to it, was 3x plus y equals 5. So here's 3x plus y equals 5. And what I'm going to do is I'm substituting in 2x plus 10 right where I see y, because y is equal to it. So that means I can replace y with it. So when I do that, here's the substitution. I have 3x plus, I'm going to put parentheses around it because I'm subbing in that whole expression, plus 2x plus 10, close the parentheses, equals 5. So I'm replacing y with the expression it's equal to. Once you've done this, right, now you have an equation that only has one variable in it, and we know how to solve those. So your next step, step 3, is going to be to solve this equation, right? So solve the equation from step 2 now. And when you do this on your own, you won't necessarily write all these steps in between, but I'm writing them out so you understand what I did. So the equation from 2 was this 3x plus, in parentheses, 2x plus 10 equals 5. And here, because it's a positive 1 in front, I don't have to distribute anything through. But if there's a number in front of y, like let's say this was a 2y here, then there would have been a 2 in front of these parentheses, then you would have to distribute the number through. But in this case, a positive 1 getting distributed through just gives you itself. So this is really just 3x. I can drop the parentheses, plus 2x plus 10 equals 5. And solving this, remember you want to combine like terms. 3x plus 2x gives me 5x plus 10 equals 5. We'll subtract 10 from each side. I end up with 5x equals negative 5. And then solving for x, we will divide by 5 and divide by 5. I end up with x equals negative 1. Now, remember what I said at the beginning. The solution to a system of equations is always an ordered pair, right? It's the part where the graphs cross each other, so you need an x and a y value. We found x, so now we'll back substitute in to get y. So we know what x is. We're going to go back to one of the originals. Doesn't matter which one you pick. So I'm going to say back substitute the result from step 3 into either original equation to find the other coordinate. And just because I have to pick one of them, I'll say I'm going to sub x equals negative 1 into equation 1. Doesn't matter which one you picked. So remembering what equation 1 was, equation 1 was negative 2x plus y equals 10. And now we know what x is, right? So I'm just substituting in that value. So I'll substitute in negative 2 times negative 1 plus y equals 10. And now we solve this. So solving this, negative 2 times negative 1 is a positive 2 plus y equals 10. And then we'll subtract 2 from each side here. I end up with y equals 8. So remember, my entire solution is an ordered pair. Well, I found the x value is negative 1, the y value is 8. Make sure you recognize that the actual answer then, right, so our solution to the system of equations here would be the point x comma y, negative 1 is the x, comma 8 is the y value in that solution. The last thing you should do, right, and this is really for yourself, unless it's asked for in the problem, is to check. Remember, when you check, you want to check in both equations. The reason we check in both equations is because, remember, for it to be a solution, it has to fall on both lines. There has to be a point on both graphs. So if you only check in one, it only tells you to point on one of them. You have to show it's a point on both. So equation 1, was negative 2x plus y equals 10. If I check in here, I'm really just substituting in. So it'll be negative 2 times x, which is negative 1, plus y, which is 8. That does equal 10. Negative 2 times negative 1 is 2 plus 8 equals 10. Yeah, 10 equals 10. Checks out in equation 1. Checking in equation 2. Equation 2 was 3x plus y equals 5. As we check this, 3 times negative 1 plus y is 8 equals 5. 3 times negative 1 is negative 3 plus 8 equals 5. Negative 3 plus 8 is 5 equals 5. So it checks there too. So the first one tells you it's a point on line 1. The second one tells you it's a point on line 2. Since it's a point on both of them, it's a solution. So the solution is negative 1 comma 8. So a couple things to point out. We first found x when we did this, and that's because we originally subbed in for y, right? We isolated y originally. If you had isolated x in the first step, the first variable you would have found would have been y, and then you would have gone back to sub in to get x. And that's okay, just make sure you put your answer in the correct order, right? X comma y. Let's do another one. This time I'm not going to write all the steps out. We'll kind of just do it together, but just so you had the process in your notes, I wanted to make sure you saw that. So, for this example, all right, if I say solve by substitution, and the first equation we'll put 3x plus y equals -1. I'll label this equation 1. And the second equation will be x plus 2y equals -12. We'll label this equation 2. Now make sure when you copy this down you do the correct signs. If you don't have the correct signs on the values, it won't work out correctly. So first thing you want to do when you're solving by substitution, remember, is isolate one of the variables in one of the equations. Now you can pick any equation and any variable you want, but it's easiest to pick ones that have coefficient of 1. So if I'm going to try to isolate here, I would either isolate y in equation 1, because I notice it has a coefficient of 1, or I would probably try to pick x in equation 2, because that has a coefficient of 1. I wouldn't likely pick the 3x or 2y, but if you have to, you can. You're just working with fractions, which makes it a little more challenging. But I'm going to choose, just to see it in a little different way, I'm going to isolate x in equation 2. All right, so just do it a little differently. I'm going to isolate x in equation 2. So equation 2 was x plus 2y equals -12. And then to isolate x, remember you want to get x by itself, means I'm going to subtract 2y from each side. And so I end up with x equals, this is -2y minus 12. Remember, they're not like terms. You can't combine those. So you just write them next to each other on the line, keeping the sign with the value. Or keeping the sign with the term. Once I have that, I isolated x in equation 2. Now I want to sub this, right? So the idea is that you take whatever you had here and you want to sub this in. That's why it's called substitution, right? So I'm going to sub x equals -2y minus 12 into the other equation. In this case, I started with 2, so this will be into equation 1. You never want to sub it back in for itself because then you'll just get an identity automatically, and that's not solving the equation. So we're going to sub x equals -2y minus 12 into 1 for x. From I want to say for x. You're replacing the x. Okay, so let's write out what equation 1 was. So equation 1 was 3x plus y equals -1. And I'm going to sub into here for x. So what I'm really doing, remember, is I'm replacing x with whatever it was equal to, the -2y minus 12. So here's this 3 in front. This means 3 times x, so it's really 3 times whatever x is, which is -2y minus 12. Close that parenthesis. That's all replacing x. Don't forget this plus y. Sometimes people lose that. And it's equal to -1. If you do this properly, right, you should have an equation that only has one variable in it. So in this case, we only have the variable of y, which means we can solve it for that variable. So I'm going to distribute through. 3 times -2y gives me -6y. 3 times -12 gives me -36. And then plus, we've got y equals -1. And you want to combine like terms. Combine like terms, -6y plus y is a -5y minus 36 equals -1. We're going to add 36 to each side. Isolate the term that has y. So you've got -5y equals -1 plus 36. 36 minus 1 gives you a positive 35. And then you want to divide by -5, divide by -5, make sure you divide by the negative. You get y equals -7. Now, am I done? The answer, remember, is no, because I'm trying to solve a system. The solution to a system is the x and y value where they intersect, right? It's the ordered pair where they intersect. So I have the y value. So now what I'm going to do is I'm going to back sub. All right, so now we're going to back sub into, now it doesn't matter which equation you pick, either of the originals. I'll back sub into 2, just to, so you know what I did here. So back subbing into equation 2. Equation 2 was x plus 2y. Right, so x plus 2y equals negative 12. And we're subbing in for y, right? So I'm substituting in negative 7. Make sure you sub it in the correct spot. It's y equals that. So we have x plus 2 times negative 7 equals negative 12. So you end up with x. A positive times a negative makes this negative. 2 times 7 is 14. So x minus 14 equals negative 12. And then you're going to add 14 to each side. To isolate x, you end up with x equals negative 12 plus 14 is a positive 2. So my solution, remember, ordered pair where these lines intersect, x comma y. The x value is 2, the y value is negative 7. You could do a check on this on your own. I'm not going to check every single problem we do. But if you wanted to check it, you could. Remember, when you check it, you substitute it into both equations and make sure it works for both of them. That shows you that it's a solution. Let's take a look at another one. If I said to solve by substitution, and I gave you 3x plus 2y equals 6. Call that equation 1. And x minus 4y is negative 12. I'll label that equation 2. So remember, the first thing you want to do is isolate one of the variables in one of the equations. The easiest one for me to isolate in this case, I would pick to isolate x in equation 2, especially because, right, the other ones all have coefficients, all the other variables do, and x doesn't have a coefficient other than 1, which makes it easier to isolate. You could isolate other ones if you preferred, but you'll have fractions a lot of the time. So when I go to solve this, I'm going to isolate x in equation 2. And when I do that, right, we had x minus 4y equals negative 12 to isolate x. I'm going to add 4y to each side. So you end up with x equals, because those cancel, positive 4y and then minus 12. Now remember what you want to do with this. You want to sub it into the other equation. So we're going to sub into equation 1 for x, right? So I started with equation 2, so I'm subbing into equation 1. I'm subbing in for x, whatever you isolated. So I'm replacing x with this. So remember, equation 1 was 3x plus 2y equals 6. And so I'm replacing x there. So this ends up being 3 times 4y minus 12 plus 2y equals 6. And then we'll distribute through. So 3 times 4y is 12y. 3 times negative 12 is negative 36 plus 2y equals 6. Combining like terms, we got 12y plus 2y gives me 14y minus 36 equals 6. And then solving this, we'll add 36 to each side. End up with 14y equals 6 plus 36 is 42. And then divide by 14, divide by 14. I end up with y equals 3. Now once you have that, right, you can sub this back into either of the original equations to get the corresponding x value. Remember, it's not just y equals 3. Don't stop here. You also need the x value that goes with it. To find the x value, sub into either of these originals. I'll sub into 1 just to show you that it doesn't matter which one. So if I sub, it's really a back sub, right? So we're going to back sub into equation 1. Remember, equation 1 was the 3x plus 2y equals 6. We're subbing in for y. Make sure you replace the correct variable. So this ends up being 3x plus 2 times 3 equals 6. So we end up with 3x plus 2 times 3 is 6 equals 6. Solving this, subtract 6 from each side. I end up with 3x equals 6 minus 6. Well, that's 0. That's okay. Don't let that throw you off. How do I solve for x? Well, you want to divide by 3. Divide by 3. You end up with x equals 0 divided by any number, remember, is just 0. So your solution, x comma y, is 0 comma 3. The order matters, right? X comma y. So don't forget that 0 is a possibility. It's a number just like anything else. You could also get fractions for these, and that's okay too. You know, a lot of the examples you'll see probably won't have fractions just because we're trying to test you on the procedure rather than your ability to work with fractions. But it is important to understand that 0 is okay for a value. So is any other number, including fractions. But this is the point where these two lines intersect. That's what makes it a solution. All right, let's try just a couple more. If I said to solve by substitution, and the first equation will be y equals negative 3x plus 8. I'll label it equation 1. Second equation will be 6x plus 2y equals 9. I'll label that equation 2. So once you have this, you know, you want to solve this by substitution. And you want to isolate one of the variables in one of the equations. Now notice you already have y isolated in equation 1. So if you already have that isolated in equation 1, you immediately could take this value for y and sub it in for y in the other equation. So what I'm going to do here is I'm going to sub, all right, equation 1 into equation 2 for y. Because you've already isolated it, it actually saved you that first step. So if I do that, I end up with this 6x plus 2 times, now we're replacing y with whatever y is equal to, so you need parentheses around this. So it's 2 times negative 3x plus 8. And then this equals 9 we had here. Alright, so this is equal to 9. And then I want to, since I only have one variable, I want to solve for that variable. So I have 6x plus, distributing the 2 through, positive 2 times a negative 3x is minus 6x. Positive 2 times a positive 8 is plus 16. And this equals 9. Combining like terms, 6x minus 6x. Well, those cancel. That's really a 0x, right? Which is just 0. I end up with 16 equals 9. So now what? Well, this happens occasionally, right? So the variables cancel out. And if the variables all cancel out and you get something that's false here, we call this a contradiction, right? So this is false because 16 doesn't equal 9. Right? So 16 and 9 are not answers here, right? This is just telling me I get a false statement because all the variables canceled. So this is false. We call this a contradiction. If you get a contradiction here, so if everything, you know, cancels out in terms of the variables and you get something that's false at the end, a contradiction, that means that these lines, right, pretty much never cross. All right, so they never cross. The answer here is actually no solution. The reason is that this tells you the lines never cross. If lines never cross, it really is telling you that they're parallel. But the answer here, right, the actual answer you need to write is no solution. The reason it's no solution is that these lines are parallel lines. In other words, if they're parallel lines, they never intersect. So, you know, there is no solution for them. Because remember, the solution for a system is the point that they share where the lines cross. if you were to get equation 2 into y equals mx plus b type form, in that slope-intercept form, you would notice that the slopes would be the same, right? That's what parallel lines have in common, but they'd have different y-intercepts. So this can happen. Just make sure you're aware of it. Right? It doesn't happen often, but it can happen, and if it does, you want to make sure that you know how to handle it. So if all your variables cancel out and you get something that's false, meaning a contradiction, then you know the answer is no solution because the lines are parallel. Let's take a look at one more. If I said to, again, solve by substitution, and the first equation I'll give you is x equals 5/2 y plus 3, I'll label that equation 1, and the second one will be negative 4x plus 10y equals negative 12, and we'll call this equation 2. So when I look at this, right, solving this system, again, the first thing you want to do is isolate one of the variables in one of the equations. Well, if you notice, in equation 1, we already have x isolated. So right away, I could think about just subbing it in for x into the other equation, because I already have done that first part. The first part's done for us. The variable is isolated. So we can substitute into the other equation with it. Don't let the fraction throw you off. Sometimes there's fractions. We just have to deal with them. So when I substitute into here, right, I'm really going to do subbing in, x into equation 2 now. I have negative 4 times replacing x with what it's equal to. 5/2 y plus 3. Plus here we have 10y equals negative 12, right? So I'm just subbing in that x value, or subbing in for that x value from equation 1. And then I'm going to distribute through, right? I want to solve for y. I have only y's in here. Well, distributing through, negative 4 times 5/2 y. When you multiply a whole number times a fraction, you can multiply the whole number right into the numerator, and then divide by the denominator if it divides out. So we got negative 4 times 5, which is negative 20, divided by 2 makes us negative 10y. Negative 4 times a positive 3 makes us negative 12. Here this positive 10y stays, positive 10y. And it's equal to negative 12. And now we want to combine like terms. So negative 10y plus 10y, well, those cancel to a 0y. They cancel out. So similar to what we had above, but now we got negative 12 equals negative 12. So all the variables canceled out, but this time we got something that's always true. We call this an identity. Something that's always true is an identity. All right, this is always true, just so you know what we're looking for. So if this is always true, that means that every point on one line is also on the other line. In other words, it means that they're the same line. Right? This tells you that they're the same line. And if you have the same line, that means they share an infinite number of solutions, right? All the points on one line are also on the other line. So we say that this has infinitely many, or an infinite number of solutions. Don't just write infinity. It's not that. It's not infinity. It's saying that there's an infinite number of solutions, meaning every point on one line is also on the other line. And really what that means is that, the lines overlap. They're right on top of each other. If you were to get equation 1 and equation 2 both into the y equals mx plus b type form, you would see that they both have the same slope and the same y-intercept, making them the same line. So it's not every point in the world, but every point on one line also is on the other line. So these are two unique cases, these last two we did, where the variables canceled out. If the variables cancel out when you do substitution and you get something that's always true, an identity, it's infinitely many solutions, meaning they're the same line. If you get something that's always false, like we had above, that tells you that you have a contradiction, meaning the lines never cross, they're parallel lines, and then there's no solution. So watch out for those special cases, but otherwise, majority of the time you will be using substitution to solve for one of the variables and then back substituting in to find the other variable. Remember, your solutions are always ordered pairs, x comma y. You need both in there. All right, so hopefully this helps.